No. 90?
We are talking, yes, yes, you're right. Pi over 2 and 3 pi over 2. And now let's determine x. So from this equation, can anyone solve for x? From this equation, can anyone solve for x?
Pi and 3 pi.
Yes. So x equals pi and x equals 3 pi. However, 3 pi does not fit in our interval, but pi does. Because the interval is pi over 2, 3 pi over 2. So then x equals pi fits in here, but 3 pi does not. Okay, so we found the answer. So our C is pi. So C equals pi. And that's what Rolle's theorem says. One more theorem called the mean value theorem.
Okay.
Say it again, Victoria.
Could you please have another question from
Yes.
the Rolle's theorem?
Yes, of course. Of course.
So you can do number 10.
Okay, so in number 10, we have f of x, x to the third minus 2x squared minus 4x plus 2, and the given interval is this. Perfect. So we have three hypotheses. F of x is continuous, yes, or negative 2, 2 is continuous everywhere, is a polynomial function. F is differentiable on the interval negative 2, 2. And now, for sure, it's a polynomial function, no corners, no vertical tangents, no cusps. So now, in number 3, I have to find f of negative 2 and f of 2. So, you know what I like to put it in? I will put it in y equals, clear everything, and I have x cubed. I have minus 2x squared. I have minus 4x and plus 2. Okay, so all I have to determine is for negative 2 and 2. And I hope they are the same. They are the same, they equal negative 6. So then all three conditions or hypotheses of Rolle's theorems are fulfilled. So then I'll say then, by Rolle's theorem, there is at least a C, at least, in the open interval negative 2, 2, such that f prime of C is 0. Okay, so I find f prime of x as 3x squared minus 4x minus 4. It's f prime of C if you want, or just x for now. I put it in the calculator again. In apps and 9, and the coefficients are 3, negative 4, negative 4. 3, negative 4, negative 4. And just give me the answers. So I have x equals negative 0.667 and x equals 2. So, because both of them, so this is a situation, a very specific situation that I cannot include because C has to be in the open interval. It cannot be 2. So this is guaranteed by Rolle's theorem, because it has to be in the open interval. Is this better? Do we feel better about it?
Yes, I'm thinking it.
Thank you. Other questions here? Anything else? Okay, so let's look at the mean value theorem now. Sorry, just 1 second. I don't want to confuse anyone. I always hope that my students will go back and look at this. Okay, so I'm on page 8 now. The mean value theorem. Okay, same thing. F of x continuous on a comma b. Number 2, f of x differentiable, at least on the interval a comma b. No third one. And let's take a look now. So there is no requirement that the function to start at one point and end at the same level. So if that's the case, then here's the function in question. This is, of course, a, and I know you're going to say f of a. This is, of course, b, and I know you're going to say f of b. Yes, I'm also going to connect the 2 points with a line segment. If you want, we can call this AB. Okay, so before we draw the conclusion of the mean value theorem, can anyone give us the slope of the line AB? And I will write it. There's no calculus here, just algebra right now.
Is it f of b minus f of a over b minus a?
Absolutely. F of b minus f of a. I have this fly here. B minus a. Okay, perfect. So, I don't like that in there. Good. What would I do without whiteout? Nobody knows. Okay, perfect. So now here's what I'm going to do next. I am going to draw a parallel line, another parallel line, another parallel line, another parallel line, another parallel line, till the parallel line that I have right now touches the function in one point. It's tangent to it. Okay? So I'm just going to do that. Parallel, 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 parallel. Stop. And draw a tangent. Done. Okay. So, of course, this will be our famous point within the, whatever you want to call it. I'm going to call it P if you want, with x coordinates C. Now, forget about this for a moment. Can you please tell me the slope of the tangent at P? Can anyone give us the slope of the tangent at P? This is what we've been doing for the whole semester, so I'm expecting you to say this very fast.
F prime of
Very good.
Yeah.
F prime of C. Awesome. But obviously, I drew parallel tangents. So what is the slope? What is the relationship between the slope of AB and the slope of the tangent at P?
They're the same.
Absolutely. Thank you so much. So, oh, maybe this is not a good color. So then F prime of C must equal
Equals.
F of B minus F of A over B minus A. So, if these two conditions are fulfilled, then by MVT, mean value theorem, MVT, by MVT, there exists at least a C in the open interval A comma B such that f prime of c equals f of b minus f of a over b minus a. It would be nice to go into sophisticated examples of this. We're just going to go to the simple ones to see what does this say. Well, it says a lot. It says about the rate of change. So that if I want to determine the rate of change between these two, right? If I have these 2 points, I could determine the rate of change using the slope of the tangent line at P. There are other applications about polynomials, etc., etc. We're just going to look at the simple applications. So let's choose. Verify that the function satisfies the hypothesis of the mean value theorem on the given interval. Then find all numbers C that satisfy the conclusion of the mean value theorem. So let's illustrate with an example. You choose, or I will. Okay. 17. Very good point. For x, we need to see as many functions as possible. 1, 4. Awesome. Good. So we know the graph of natural log. We know that this is 1 and this is 4, obviously continuous and differentiable everywhere. But I have to write it. F continuous on 1, 4. 2. F differentiable at least on 1, 4 open. Then by MVT, there exists a C in the open interval 1, 4 such that f prime of C equals f of B minus f of A over B minus A, where this is A, of course, and this is B. So first let's determine these two, f of A and f of B. So here's the function, f of 1. How much is f of 1?
Zero.
Yes. How much is f of 4? You can only say natural log 4. That's good enough. Now let's find f prime. Can anyone give us f prime of x?
1 over x.
Excellent, 1 over x. So then, f prime of c will be 1 over c, this part. And this part will be f of b, which is f of 4, which is natural log 4, minus 0, there is no point in writing it, over 4 minus 1. But 4 minus 1 is 3. So I have no idea why this is not keeping it in that place. Okay, so in a proportion, I can reverse or use the multiplicative inverse, just swap both sides. So then c equals 3 over natural log 4. This has to be in the interval 1, 4. If it isn't, I made an error somewhere. Why? Because as long as the function is continuous and differentiable, this is guaranteed. At least one I have to find. So I'm just going to plug this in the graphing calculator and make sure. I cannot write this statement before I check. I have to divide 3 by natural log 4 and see if it's here. Otherwise, this means nothing. So I'm sharing my screen again with... Okay, so we have 3 divided by natural log 4. So it's 2.16. So what I wrote is correct, because this is approximately 2.16, which is definitely a number between 1 and 4. But I have to check. How do we feel about the mean value theorem?
Can we do another problem?
Sure. Oh, I didn't mean that. I meant this. Yes. Anyone would like to choose?